Okay, we are back. This is Basic Statistics. We're looking at the notes for Chapter 2. So, organizing data, frequency distributions is the name of the game. Organizing data using frequency distributions, representing data and frequency distributions graphically using histograms, frequency polygons, and ogives. All right, so let's take a look. First of all, again, we talk about the difference between inferential and descriptive statistics. Inferential means I'm going to make an inference about a population based on a sample. We're going to do that later. This is descriptive statistics. That means I'm going to come up with ways to describe sets of data like this and this. And so we've got the two different kinds of data here on the board. I've got, remember, the qualitative and the quantitative, or this is sometimes referred to as categorical data and numeric data. And so categorical means you can only put it in a category. So blood types, we've got A, we've got B, we've got AB, and we've got type O. And I know there's negatives, right, and stuff, and positives. But we're just looking at the basics. So blood types are our classes. Now, frequency is just a fancy way of saying how many times did that occur in your set. So type A happened 1, 2, 3, 4, 5 times. So we put 5 down. So it's really just how many. It's a count. B happened 7 times, AB happened 4 times, and type O happened 9 times. Now, at the end of each frequency table, you should always add up your numbers. So that is 12 and 13, that's 25 total. And that should always match with how many? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 25 pieces of data. So those two should always match. All right? Categorical data. This is, let's take a look at numeric data or quantitative. This is qualitative, this is quantitative data. So now they tell us, all right, grouped frequencies. They want it in groups because like the numbers aren't repeated a lot of times and things like that. And so we'll put them in different classes, different groups. So first let's find the class width. They say they want 7 classes. So 1, 2, 3, 4, 5, 6, 7. We want 7 classes. We want to split it evenly though. You can't have different size classes. You can't have one with a width of 14 and one with a width of 10. You have to always have uniform width from beginning to end. So let's take a look at class width. The first thing we do is we find the range, which is just the biggest number minus the smallest number. We divide that by the number of classes desired. So in this case, it goes from 0 all the way up to 93. So 93 minus 0 on the top, and they want 7 classes on the bottom. So that works out to be 13.28. Well, we're not going to use 13.28 for a class width. Always round that up to the next integer, so the next whole number, 14. So that's going to be our class width. Now this is a little tricky. If your class width is 14, you can, in this case, it's super easy what to start with. We'll start with the lowest value, 0, but we're going to go 0 to 13. That is a class width of 14. Lots of people don't realize it because they're like, well, wait, no, it just goes from 0 to 13. 0 counts as one of the values. So if I were to write it out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pieces of data in that class width. So the class width is 14. This was not a mistake. All right, so 0 to 13. Boundaries, you just knock off a half and add a half. So it's negative 0.5 to positive 13.5 for the boundary. All right, so now for the next one, that is 14, by the way. If you take 13.5 minus negative 0.5, that's 14. 13.5 to, let's see, it goes from 14 up to 27. I know those are only 13 apart. If you take 14 plus 13, you get 27. But remember, 14, the number 14 also counts as one of the numbers. So it's still a class with the 14. So 13.5 to 27.5. Then we go 28 to 41. We go 42 to 55. We go 56 to 69. We go 70 to 83. And we go 84 to 97. And now we're going to put in all of these 27.5, 41.5, 41.5, 55.5, 55.5, to 69.5, 69.5, to 83.5, 83.5, to 97.5. All right, so all the boundaries, always just a half lower than the lower end and a half higher than the higher end. That's how we got all those. These replicate, these match. See the 13.5, 13.5, 27.5, 27.5, 41.5. These don't. There's no overlap in classes. 0 to 13, 14 to 27, 28 to 41, and so on. All right? Frequency is how many of these numbers fall in this boundary range from negative 0.5 to positive 13.5. How many total numbers are there? And I'm just going to tell you, it's 14. You can cancel them off and tally them up, or look, search and destroy here, 12 and 6 and 5. Just find everything between 0 and 13. You could type it into Excel. You get to use Excel this whole semester for everything, homework and tests. You can type it into Excel and just hit the sort button, and it'll put it from lowest to highest. And it's super easy to count up how many frequency, how frequent does it happen from between 0 and 13. All right, so that's 9, that's 5, that's 1, 1, 1, and 2 to end. You should always total up your frequencies. And it should always match the set of data given. So there's 33 pieces of data given. That's n equals 33. Usually n notes the number of pieces of data. So n is 33. Your frequency should always add up to that. Relative frequency. Relative frequency means relative to the set. So look, 14, 33, this is sort of the percent that falls in this category from 0 to 13. So that's 0.424, about 42%. All right, 9 33rds, 5 33rds, 1 33rd, 1 33rd, 1 33rd, 2 33rds. So we'll put in the decimal version of all of these, but you can convert them to percents by just multiplying by 100. So this is 0.061, 0.030, 0.030, 0.030. So about a 3% chance that it's going to fall into any one of those. 5 out of 33, so that's about a 15% chance, 0.151, and 0.273. All right? Cumulative frequency just means it's a running total. So look, this is 14. There's 14 that fall in from 0 to 13. But then what if I asked, okay, this one, what if I said, how about from 0 to 27? Well, that would be 14 plus the 9 more, so that would be 23. And then what if I said, well, no, how about from 0 all the way up to 41, from 0 to 41? So that's 23 total with those two, and then 5 more on top of that, 28, 29, 30, 31, 33. All right? Think of it as kids on the bus. 14 kids get on, and then 9 more get on, so we're up to 23. And 5 more get on, and we're up to 28. And 1 more get on, we're up to 29. And 1 more get on, we're up to 30. And 1 more get on, we're up to 31. And 2 more get on, and up to the third degree. So that should be, the cumulative frequency is just a running total. You can also do relative cumulative frequency where you're just adding up these percents. So you're just taking that 0.42 and kicking on the 0.27 for that one, and then adding 0.15 more for that one, and then adding 3% and 3% and 3%. All right? Oh, by the way, if we total up these frequencies, that should total up to 1, but if you actually do the math in your calculator, add all those up, it comes out to be 0.999. It should be 1, but that's just round off here, because we went to thousands place. If we would have went to millions place, it would have worked out to be 1. All right? Okay. So we talked about boundaries. We talked about frequencies. So this is a frequency table. Now we use this information to create graphs and charts. So on page 3, let's see, cumulative frequencies, just a running total. Page 3 of the notes here on chapter 2. There should be between 5 and 20 classes. Remember that. Never less than 5, never more than 20, because that's too many. Preferable to have class widths be an odd number. It's nice, but that's not a requirement. Odd numbers make better for finding the midpoints. We didn't find the midpoint here. We'll do that later in the notes. Mutually exclusive, so no overlap. Classes can't overlap. 0 to 13, 14 to 27, 28 to 41. Class widths. Classes must be continuous. We can't skip a class just because there's no elements. Gaps are important too. Classes must be exhaustive. All the data has to control it or capture it. And classes must have equal width. So you can't say, oh, this is 14, 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 this is 14. And then you turned out that there's a piece of data that's 98. And you're like, oh, we'll just make it 15 so it all fits in 7 classes. You're not allowed to do that. You gotta adjust the class width if that happens. All right? On all of them, not just on one of them. All right. So we're going to use the same data, and we're going to make some charts on the next video. That was 2.1, and we're at 12 minutes. Yeah, fine. Let's leave this here. I'm going to leave that data right there. I'm going to erase this, and we'll make ourselves a histogram. So these are easy. These are on the test. Now look at this, week 1 already, and we're talking about the test. You got to remember here with this course, we're jamming it in. We got a lot to cover in only 7 weeks. So we have a test coming up already. So what does a histogram look like? A lot of people mistake a histogram with a bar chart. It is not. A histogram is contiguous. That means there's no breaks in it. Bar charts have little breaks in between it, all right? And so what we do for this is we make sure to label. So let's see here. The data that we have here, oh, this is awful data. That's the other thing. Get used to that for the summer, the semester here is the data that we collect usually isn't how many people like puppies and things like that. It's usually kind of a little on the dark side because we're worried about, how can we stop people from dying? How can we, this is unhealthy days in a city, meaning like where the air isn't really cool to breathe because there's so much smog. And so that's what's going on with this data. All right, so we have it all set out. What we do for a histogram is we take our boundaries, and that's what goes across the bottom. So we have these boundaries here. I'm going to actually have to extend the x a little and go to negative 0.5. Usually it doesn't do that, and it starts at 0 usually. And then we're going to go 13.5. We're going to make all of these, uniform. So you don't want to have any skips. You don't want to go from here and then jump to 30 or something. We're going to do 27.5. And the next one is 41.5. And the next one is 55.5. Next, 69.5. Next, 83.5. And 97.5. All right. So we've got all of our boundaries in there. And now on the bottom, this is, so here, we'll give it a name, or call it cities. On the bottom, this is unhealthy days. And going up the side, this is frequency. How frequently did it happen? So we look at our frequency chart. 14 is the top dog. We can go by 5s. I mean, you could go by 2s, 10, 15, 1s. Really, even with 15, you could go by 1s if you wanted to really be precise. That's fine. But this is always, the X is always your boundaries. So that's always your boundaries. And notice, remember, we have shared boundaries. The 41.5, the 41.5, the 27.5, like that. Those are shared. So they're going to be shared here. So we have our first one at 14. So I'm going to make a bar. Go to 14. Now, if you look at my notes, I did a little cheat on there, which you can do too if you want to, where I put the actual number, the actual raw data right in the bar. That's not a requirement. You can do that if you want. If you have really precise, a really good drawing, you probably don't need that because you would know it was 9, you know. I don't, so I'm gonna kind of cheat and use that. 5, and then we had a string of 1s, right? So all I'm doing is putting this data down in a visual manner. And then up to 2. And there's our data in a histogram, a frequency histogram. And so we remember the title, and we remember to label. Title and label. That's important on the test. That's going to be like 3 points out of the 8 that you're getting for this. And so I don't want you to lose 3 easy points just by putting numbers down. Okay, and so 14 and 9 and 5 and 1 and 1 and 1 and 2. And so this is a visualization of our raw data right there. All right. We're going to throw in one thing here for the next one is a frequency polygon. So we're going to take a look at that, a frequency polygon with the same data. We're going to do a frequency polygon, which looks just like this. Here, I can, but we also need the midpoint to do that. So here, let me check the time. Okay, yeah, we can get this knocked out. So the midpoint is the middle of the class width. So here, look, I have it written out right here, 0 to 13, right? 0 to 13. There's 14 pieces of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So right here, there are 7 above and 7 below. That is the midpoint or median of the set. So the midpoint is halfway between 6 and 7. So you take 6 plus 7 and divide it by 2. That's half of 13. That's 6.5. Now, a lot of us, you just probably thought, I don't have to do that. I knew between 6 and 7 was 6.5. That's fine. Now, this is a special case. The lower part is 0. And so when you're finding the midpoint, you don't have to do that for every one of the classes. That would be very tedious to write out 14 through 27 and find the middle, and 28 to 41 and find the middle. Basically, it's going to be the same distance off of the top or the bottom. So you could either take 6.5 and subtract it off the 13, that would be 6.5, or 6.5 minus 0, that would be 6.5. and then take that amount and add it to the lower end or subtract it from the higher end. Either way, it's the midpoint. So it doesn't matter if you subtract 27 minus 6.5 to find the middle, or if you take 14 and add 6.5 to find the middle. And so I'm going to add to find the middle. And so that's going to be 20.5, 34.5, 48.5, 62.5, 76.5, and 90.5. And so basically, how did I get that 90.5? I took 84 and I added 6.5, the difference between the lowest value and the midpoint. All right? So there are all my midpoints. Now we're going to do a frequency polygon, which is very, 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 very similar to that histogram we had up here. I'll cross off histogram and put polygon. So frequency polygon, what we're going to do is we're going to use these midpoints as our markers. So 6.5, 20.5, 34.5, 48.5, 62.5, 76.5, and 90.5. That again is unhealthy days. And this again is frequencies. So we can do the 5, 10, and 15 again. And this is for cities, big cities. All right. And so now 6.5, that's 14. So we put a dot right there at 14. 20.5 is 9. So we'll put a dot right there. 34 is 5. 34.5 is 5. 111 and 2. And so just like the histogram, for the heights are all the same as the histogram. If you take a look, this general shape, you know, we had little boxes there. This would be in the middle of those boxes. But here's the extra additional thing. It should always jump from like the x-axis and then just have it go down to the x-axis, wherever. I mean, if you want to be like that, you could add 6.5 and say that's 97, and you could subtract it and say that's 0 if you want like precision on those. But it doesn't really have to have a value on either one of those. But in a true frequency polygon, it should always start and end on the x-axis. But the shape is exactly the same as the bars if you flip the page back. All right? So on the next video, we'll pick up right there, and we'll do ogives.